చెప్తున్నారు. ఓకే. Even alkyl halide, wherein this X may be chlorine or bromine. When treated with sodium iodide, we get alkyl iodide, along with that, of course, sodium halide. See, this reaction is a very important reaction called Conant-Finkelstein reaction. Okay, or simply Finkelstein reaction. It is actually based on Le Chatelier principle. Dry acetone is also used here. Sodium iodide is more soluble, whereas sodium chloride and sodium bromide are less soluble. Okay, because these are less soluble, they are precipitated. Less soluble in acetone. So they are precipitated. Now, the Le Chatelier principle. See, here we get sodium chloride, sodium bromide precipitates because they are less soluble. Right. Now, in this case, when the product is removed, of course, they are getting precipitated in the sense they are going out of the mixture. So when Le Chatelier principle is applied, because the product is removed from the mixture, reaction goes in forward direction when some amount of the product is removed, right? So that actually helps in getting more amount of alkyl iodide. Okay. According to Le Chatelier principle, reaction proceeds in forward direction due to the precipitation of sodium chloride or sodium bromide. Okay, this is very interesting. Sodium iodide is more soluble, but sodium chloride, sodium bromide are less soluble. Okay, next. See, in this case, because we are exchanging the halides, isn't it? Iodide is replacing the halides, Cl minus or Br minus. You know, this reaction is therefore called halide exchange method. Okay, this is very interesting. Now, one more interesting preparation. This is meant for the preparation of alkyl fluoride. See, when alkyl halides, here also the X can be a chlorine or bromine. Let us take some fluorinating agents. Silver fluoride, AgF, or mercurous fluoride, cobaltous fluoride, even antimonous fluoride. In all these cases, see, these are all fluorinating agents. The metallic fluorides, when these are used, we get alkyl fluoride along with the silver halide. Okay. This is again a very important named reaction called Schwarz reaction, meant for the preparation of alkyl fluoride. Let us consider one or two examples. Take methyl bromide. When treated with silver fluoride, we get methyl fluoride, then silver bromide. Okay. We can also consider ethyl bromide with this, if suppose Hg2F2 is used, we get ethyl fluoride, yes. Along with that, of course, Hg2Br2. Okay, so this is Schwarz reaction. One more. This one is very, very interesting. In this, we use the silver salt of carboxylic acid. Now, when this silver salt of carboxylic acid is treated with a halogen, take chlorine or bromine in the presence of CCl4, we get alkyl halide, carbon dioxide, then silver halide. Okay. Let us see the mechanism of this reaction. But before that, let me tell you that this is again a very important named reaction called Borodin-Hunsdiecker reaction, also called Hunsdiecker reaction simply. Okay. Now coming to the mechanism, it follows free radical mechanism. Let us see that. Silver carboxylate let us take bromine. Silver carboxylate reacts with bromine to form RCOOBr, bromoderivative of the carboxylic acid, and then silver bromide. Next. This bromoderivative, let me show it this way. Undergoes homolytic fission. To form free radical. Now let us consider this free radical RCOO free radical. Go for this again. It results in free radical. Combine these two. You will get alkyl free radical and of course carbon dioxide. Now this alkyl free radical reacts with the bromine. Even here also it can be shown this way. Go for go for homolytic fission again. These two combine. You will get your alkyl bromide. Another bromine free radical. Okay. So this is Borodin-Hunsdiecker reaction. So when it comes to yield, Coming to the yield of alkyl halides. A very important point. This is the experimental one. More yield of the primary alkyl halide. Similarly, if you consider the alkyl, the halogen, you get more of alkyl bromides than the alkyl chlorides. Bromides give good yield than the chlorides. Okay. Now the interesting point is when iodine is used, the reaction will be very much different. Let us see. Silver carboxylate with iodine forms an ester. That is very interesting. Yes. See, even here also it is said that if they are taken in 1:1 ratio, we get an alkyl halide, but when taken in 2:1 ratio, we get an ester. Okay, when that is also given. Let us take this one into consideration for now. See, this particular reaction is known as Birnbaum-Simonini reaction. Birnbaum-Simonini reaction, right? Next. One more preparation. See, when an alcohol is treated with halogen in the presence of triphenyl phosphate, see, that is, phosphate is PO4 minus 3. 3 oxygens have been replaced by phenoxy groups. And this. Now, this on heating forms RCH2X. You get a phenol and then this, the remaining part. Okay. Even this also is a very important named reaction. This is called Raidon's method. Okay. Next. We can also take this one from the Grignard reagent. Plus X2. You will get 1 Rx. The other one will be, of course, MgH. So this is how the alkyl halides can be prepared. Let us now go for the preparations of haloarenes. See, the first preparation of haloarenes is the one which we have already seen. In the properties of benzene, the halogenation, or you can say nuclear halogenation. Okay. See, in halogenation, we know that the electrophile is halonium ion. See, when benzene is treated with the halogen, you can consider chlorine or bromine here. For convenience, take a hydrogen out. Anhydrous aluminium halide, aluminium chloride or aluminium bromide. This, of course, is an electrophilic substitution reaction. You can just remove HS. I have already given the mechanism. You can see that in benzene topic. But for now, see, we got halobenzene. Okay. A property of benzene, here it is the preparation method of haloarene, right? See, with iodine, the reaction is very slow. In fact, it is a reversible. We get iodobenzene plus, of course, HI. Again, the same thing. H, then I. But you know, because the reaction even goes in backward direction, because of the reversible nature of this reaction, to prevent the backward reaction, we need to remove this somehow. It has to be converted into some other form. So to prevent the backward reaction, strong oxidizing agents are used. See, the strong oxidizing agents include mercuric oxide, iodic acid, HiO3, HNO3. Okay. Now see, these oxidizing agents oxidize Hi into iodine. Okay. This is nuclear halogen. Now, supposing if toluene is taken, see this methyl group is an activator. Of course, it is a weakly activating group. And arthopara-directa. When this is treated with chlorine in the presence of anhydrous aluminum chloride, again electrophilic substitution occurs to form artho and para products. Okay. As usual, the para product will be major and the artho one will be minor because of steric hindrance. Okay. Now let us see side chain halogenation. Let me give you this example. Let us again consider toluene when treated with a chlorine in the presence of sunlight. You know, this side chain halogenation is a free radical substitution reaction. It can be carried out using different reagents like chlorine in the presence of sunlight. You can use sulfuryl chloride either in the presence of sunlight or traces of peroxide. You got NBS, you got NCS. See, in all these cases, see, this carbon is benzylic carbon, right? And the hydrogens are benzylic hydrogens. With chlorine in the presence of sunlight, we get CH2Cl. This is called benzyl chloride. On further reaction, we get benzyl dichloride, CHCl2. Okay. Further, we get benzo trichloride. So this is side chain halogenation. Previously, we have seen nuclear or a ring halogenation. Look at this interesting example. Supposing if we take something other than the methyl group, I mean a side chain larger than the methyl group. In such a case, the side chain halogenation or the free radical substitution occurs at the benzylic carbon. Okay, look at the product. Now this, where a benzylic hydrogen is substituted, we also get this. Right, but this is major, this is minor. So let me tell you that when side chain is larger, than methyl group, free radical substitution takes place at the benzylic carbon. Okay, this is very important.